For you, mate, definitely yes.
Thank you very much. We're sort of, we keep building it up, so I owe you a car in the end.
Yeah, yeah, definitely. Take my pick. Welcome to the Bracket Factory, and welcome to this episode, which is all about Bryan's gearbox. Now, if you've been following the channel, you'll know that I took a trip down to see Bryan, and he very kindly gave me the opportunity to sort out this gearbox. It's a tiny little thing out of a 1949 Crosley, but unfortunately it's had a very hard life. And there are now two things which need to be sorted out. One, the gear selector mechanism doesn't work. It's totally worn out. And two, there is absolutely no clutch release mechanism. No arm, no bearing, no nothing. So we've got to sort that out as well. So I think the first thing we're going to do is take a look inside. So I've whipped the top of the gearbox off, and I can now see all the selector mechanism in all of its glory. It's basically completely knackered. All the parts are completely worn out, so clearly I'm going to have to take it all to pieces. I can see that these selector forks are held in by these pins, so I'm going to have to get these pins out somehow. And when I've got the shafts out, I'll be able to remove the detent mechanism out of these end holes. And when all that lot's out, I'll be able to take the gear lever part out, which has got a ball joint inside there. Right, we can see there's a spring inside there. It looks like quite a vicious spring. Looks like it might try and kill me when I take it out, so I have to be very careful. There it goes. Right, now it would come out if we hadn't got a thing welded to it. Right, it's all in pieces now, so we can have a good look at all these parts. They're all a bit grim. This is the sort of stuff that we're worried about. These surfaces here. It looks a bit worn. This is particularly bad. Oh, dearie me. But we can't really have a good... Oh, that's also pretty bad, isn't it? Look at that. That is very bad. But we can't really tell the nature of the beast until it's all been cleaned up. So I think the next step is I'll clean it all up. I won't bore you with that bit. It's a bit dull. So I'll just clean it all up and I'll report back. Right, sometime later, lots of elbow grease consumed, and I've cleaned these parts and we can review the damage. So let's start off with this bit. So the biggest job was grinding off the soldering welds. But they're ground off now. I should go and have a word with Bryan about that. So they're removed. But obviously the two important parts of this are this groove here, well, what's left of it, and this sort of paddle here. Now this is what engages in these cutouts in that shaft and this selector fork. And this should be A, round, and B, have square edges. So you can see that is properly buggered. The technical term for the whole thing is completely knackered. So that needs sorting out. Now this groove engages in a pin in the side of there, and that rotates. So it's a combination of that groove and that pin are both knackered. Turning to these shafts, heavily pitted and rusted. Now these are the detents which holds it in position. These are heavily worn, which is a problem, and also this edge on this where this lever engages is worn as well. Obviously it's been doing that. On this one, the detent is heavily chipped and broken. Good news about this one is that we can rotate this one through 180 degrees and get some fresh meat. And this fork is heavily worn on there. Oh, one more thing. These are the detent pistons, if you like, and this forms a double function. Not only does it act as a detent, but it acts as an interlock. And what I mean by an interlock is if we've got both these shafts in here like this, the dimensions of these pins are such that they can't be both compressed together, which would enable you to change gears on both sides simultaneously, because of the dimensions of them. They're too wide. But because they're worn, you can select two gears simultaneously. So these need to be remade as well. But apart from that, it's immaculate. It's in excellent condition, and there's really nothing that needs to be done at all. So before we start tackling all of these things, I think the next thing to do is we have to get this pin out. How that is held in, I don't know. By some magic force, you can just see the shadow of it there. It may be screwed in, it may be pressed in, it may be welded in. I don't know how. First thing I'm going to do is just try and knock it out and see how we get on. But once I've got that out, then we can actually start to try and repair this thing. Right, so this pin is now out. Turns out it was just a press fit, and it's got a slight shoulder on it. Now, because I can now see the original dimensions of the pin, which is around 7 point, what is it? Well, I can measure the hole, and the hole is just under 7 millimeters, 6.75, probably an imperial measurement, 6.75, and then we measure the width of the groove, 9. So you can see how much this is worn. It's totally, yeah, worn out. So I think now I'm going to put this to one side. I think the first job is attempt to sort of repair this piece, obviously this groove and this. So what I'm going to do is I'm kind of going to grind out any of this bit pitting, because it'll make welding harder, and then lay up some weld around here and around there, and then dress it. And you can see a slight machining mark there, so that tells me that this paddle was originally 7.5 mil wide, and it's down to 6.2 down there. So weld all that up and machine it, grind it, machine it, whatever. And also I'm gonna, this has got a massive deep pits. Look, it's really weird. It's like at the bottom of the sea. So I'm gonna kind of grind this out and run some weld up along these sides. So let's do that next. Right, so I've put some weld on this, and I think that bit is fine. I'm going to have a sort of a 6 millimeter groove down there. This bit here, I think I probably still need a little bit just there. I don't really want to machine and fettle this and then find I've got a bit missing and then do it all over again. So put a bit in there, put a bit in that little hole there, I think, and then we can start to sort of fettle it up. Right, back at the bench, and a lot of fettling later, this piece has been repaired. So I've machined this new slot in there, which is 1/4 inch in diameter. So basically that's the size of the hole. So there's going to be 1/4 inch pin in there. So that's fine. And as you saw, I did it on the indexing head so that I can make sure that that slot is completely perpendicular with this face here, and I can flip it over and get that, you know, completely parallel on the other side. So this this width here, where's my vernier calipers? This width here is now 7.2. I was aiming for 7.5, but that's fine. It's obviously about 3mm thicker than it was. This is 14.4. I was aiming for 14, but if I offer it up to these pieces, I might need to do a tiny bit of fettling, but I'll cross that bridge when I actually assemble it and try it all out. But that is significantly better. And the key thing is that these shoulders are nice and sharp. They were just completely worn away. And what I had to do, I machined it, and then I didn't quite have these sharp corners, so I had to then put more weld around here, more weld around there, 3 of the 4 actually, and then do a bit more fettling, but it's all right now. So I think with this, we're 90% there, because that is a good fit. And on one of these, this one, not this one, this one, that is also a good fit. To get off remaining 10%, what I think I need to do is this surface here is pitted. So I'm just going to grind that back, weld it up, and then machine that with the milling machine, and then put this in the lathe and clean it all up. So I think once we've done that, we're looking pretty good. I might also tackle this surface here, depending on how positive the gear change is. So I still need to do that. And then of course we've got these little detent pistons, and you can see, I don't know whether you can see, but they are completely worn away. So I might try and just put just a blob of weld on top of there, and then just re-profile them into a dome. So we're getting close. A little test of this in here, if we put this in here and, oh, wrong way around, put this in here like this, put our 1/4 inch pin in there, we can't rotate it at all, so that is mission accomplished. So right, yeah, let's do a bit more welding, bit more fettling, and then we can try and assemble it. So back at the bench, and I welded this up, and I put it in the lathe and machined it round there. But what actually happened when I welded it, and this is entirely predictable by the way, is that it bent. Because by putting a load of heat in just there, when the weld cools, it contracts, and it basically pulled it round. So when I put it in the lathe there, this was going all over the place. I didn't show that, but basically what I did is put a socket over there, bent it straight again. So it's straight, machine this off. So now I'm going to have a nice surface along here for these when I've sorted that out. And a little test I can do, of course, is I can put it in here. Oh, wrong way around. Put it in here, and it goes this way, and it's absolutely fine. So that's good. So now we need to take a trip to the milling machine and machine off that nice and square. So it's like that, so that this bit engages in it. And we also need to machine this groove in here. So we got a machine round there like that to kind of put this detent groove in there. So that's next. Right, back of the bench again, and I think we're getting there. So this is now being machined, so we've now got a lovely sharp square edge just on there, and this surface is nice and smooth, and we've got our detent groove in there, so that's nice and positive, and it's nice and smooth. Now this is what it was like, and you've got a double whammy here. Not only is the detent terrible, but also this rough surface is going to destroy the pistons. Now in this one we can simply rotate it by 180 degrees, so we've got all this fresh material. So now we've got two decent shafts. We've got a decent cutout there, decent detents on both sides, and we're going to stick with this, which is not too bad at all. I mean, if it turns out to be bad, then I can weld it and fettle it, but it's actually pretty good. I've also made this sleeve to go over here. I've filed down that so it's a bit more round. Had all those welds on. That slides over like that. I think I'm going to need a bit of something decent to hold on to, because with these new detents, it's going to be much more positive, I hope. Also, we need, these are the pins that I had to drive out. So what I've done is I've made up two new pins of the same dimensions, and all I've done on these new pins is cut a slot in the end with a hacksaw, of course, and when they're in I'm just going to tap a screwdriver in those and splay them. It's basically like a split pin. So obviously these fit through here like that. Don't know quite who did that and at what stage. I've already cleaned up that one that had been hit. I'll clean that up. Just so anybody opening in this gearbox in 50 years time doesn't think, what the hell happened there? So we're getting close. What's left? So we still need to do these two, and I still need to sort this out, not this for that. Two more things. Got a cunning plan for that, so let's do those two bits and then we can start reassembling it, see if it works. Right, back at the bench, and the first thing I sorted out was this. So you saw me, I basically drilled and tapped this hole. It wasn't tapped before, but I've tapped it. And the reason I've tapped it is because I've made this. And basically it's a bolt, 5/16 UNF bolt, chopped off, put a slot in, turned down a nut to make a lock nut. And this now screws in here like this. And of course I can adjust the depth to make sure it engages exactly the right amount. Put that in there like that. Job's a good one. So I think that's going to be fine. When I reassemble it and put the death spring back in, I can just tighten this up until it binds, back it off a bit, lock it up, probably use a bit of thread lock on it, and that's good. So that was cunning plan number one, which worked, hopefully. Cunning plan number two was to sort these out. Now what I did is I put a blob of weld on top of there and tried to grind it, but to be honest it didn't work. It's got kind of little pitted holes in the weld, very difficult to grind it, and also it actually blew out the back. So I thought, you know what, I'll make some more. So here we have 2 more, which I've made. Now, as I mentioned before, it's quite clever this. Not only are these the detent, but this is the interlock mechanism. And the way it works is that the combined diameter of these two is 14 millimeters. But the width across these two is 13 millimeters. That means they both, you can't have them both free to move at any moment in time. That's 14, that's 13. That means you can't move 2 shafts simultaneously, which means you can't cock up the gearbox. You can only move 1 shaft at a time. And these have got these little recesses inside here such that the spring goes in there like that and like that, and that compresses together so that they touch. And what I've also had to do is make this little insert tool so that I can actually insert them in the side there. So I'm quietly confident that these are going to work, but the proof of the pudding is in the eating, of course. So next step is to assemble it all. I'm going to give this a bit of a clean first. It's still got a bit of swarf in it from cutting the old pins out. Assemble it, give it a test. Right, everything's all cleaned up, so let the reassemblage begin. Right, spring now in. I couldn't really film that because it was like fighting with an anaconda, but it's in and nobody died, so let's carry on. Need to turn this one through 180 degrees so I'm getting the decent side on the detent. That goes in there like that. Right, getting the other piston in is going to be easier said than done. Right, I've got myself into a bit of a pickle here because I've pushed this one in, and because I didn't slide this rod round, the detent is engaged in the cutout. Now what I'm going to have to do is now take this one out so that the detent can slide all of that way and I can get that out. So if you're ever doing this, beware of that. Right, now back where I was, I've got the detent in there. It's an absolute pig to get in. But I've got this cutout on this side facing that way so it doesn't slot into there, so I can carry on. Let's make sure I put this on the right way around. Goes, yeah, it goes that way. Okay. Right, there's another gotcha. If I insert this one in the wrong way around so it doesn't engage in there, now I can't rotate it, so it's all got to come to pieces again. Right, so the Rubik's Cube is back together. Now, when I took this to pieces, it was so worn it just fell to bits, but now it's all been re-engineered. There is a very specific sequence, and you put this shaft in first without the fork, then you put the detents in, then you put this shaft in with the fork, then you put it in one of the detents and slide this shaft back out again and thread the fork on, and then finally you put this last pin in. So I've just got to pin over these pins, but the next step is to stick it on the box and see if we can find 4 gears, well, 3 in a reverse. Right, so let's do a quick test. This is your neutral plane, and that is reverse. That is first into neutral, and that is second, and that is third, which is straight through. So back into neutral and everything's free. So job's a good one. So the next thing we need to do is swing the guns around and swing the gearbox around to the clutch. You can see I've got a clutch bearing. Right, so what have we got? We have got a release bearing. Now this was off eBay, £9. I just found something that looked, I don't know what it's off, it's like a generic bearing, something modern, Peugeot or something, and it's a Tampren 101778, £9, thank you very much. This, I obviously don't have the arm that clips onto, but we can work something out for that. This slides on there. Obviously, that's too big, so we've got to do something about that. And also, when I was at Bryan's, I measured the distance of the clutch plate from this bell housing flange, and it was 45 millimeters. And if I put this on here and measure it, it is 42. So this doesn't go far back enough. So fortunately, it's got this plastic flange on here. So what I think I'm going to do is I'm going to machine this plastic flange off, and then I'm going to make a spacer using this aluminium that slides on there and slides in there. So we're going to basically shove something on there. It's going to have a little top hat on the end so it can't slide all the way off. And that is our starting point. Down here, we've got this shaft. Now this is a very spindly 3/8 shaft, and this is a single-seater gearbox, so we're going to have a lever off here somewhere, but we can't have it off this because it'll just bend. So what I'm going to do is I'm going to have the arms working on a piece of tubing there, and then have another arm sticking down below it. So you pull on that arm, the whole thing pivots. So rather than having a bending moment, we've now got 2 shear points on here, and so that's plenty strong enough. And then Bryan will have to rig up a separate sort of lathe shaft with a clutch pedal on it, which pulls the lever to operate the clutch. So first things first, I think I'm going to whip this all off. This bearing sounds horrendous anyway. Let's have a look at that. And take the bell housing off, take this nose off, clean it up, and make this spacer. Oh, there comes the bearing. I think that's a bit knackered. Right, well, I think we'll pop that off and find. Oh, look, we can see the rollers inside there. Let's not lose those. We'll pop that off and order a new bearing, I think. But meanwhile, what we're interested in is this nose piece, because we need to make a spacer to go on here. A bit more machining, and I've made this sleeve with this little shoulder on the end, and this sleeve slides on there, and this bearing, which I've machined off the plastic, now slides on there like that. Now that sleeve doesn't actually have to be fixed to either that or that, doesn't really matter, that just slides out like that. This will just go through the centre of the clutch, it doesn't matter. The main thing is it has got the shoulder, so it doesn't sort of fall off inside the clutch. So I needed at minimum 45 millimeters from the face of there to that, at least 45, if not more, and it is 46.5, so that's fine. I could go a little bit more if I wanted to. I could make this this aluminium spacer sit flush with that and get me another millimetre if I needed, but I don't think I'm going to need it. That's fine. So now I need to turn my attention to the cross shaft. So I've got this bit of bar, skinny bar, which will run through the middle of there, and I got this chunky bit. Looks like it's 3/4. So I'm going to cut this down to size, drill a hole through it, and that's going to be my cross shaft. And when I've made that, I can start to think about 2 fingers which go up there and slot inside here, go that way, and a lever arm which protrudes down, which you pull to actuate the clutch. So let's trim that and drill it and stick it in situ. Right, so the cross shaft is now made. I didn't show making that because it was boring, both physically and metaphorically. I just had to bore a hole through the middle and generated a big pile of swarf, but nothing much to watch. So now I need to make a couple of fingers to activate or actuate this this thrust bearing. So what I typically do is start off with a cunning master plan. So this is some kind of bran flake rip-off off the neighbour, Dave. Thank you, Dave. Get some critical dimensions and come up with the design of this arm. That then gets converted to a scale drawing to scale, and that then gets converted to a pattern. Okay, so this is my pattern. So obviously this cutout pivots on there. The way it's designed is that it would slot up through there like that, and this shoulder comes up against the bottom of the bearing so that it doesn't want to rotate. It's supported on both sides, and then it's got a slight curve in it because of course it has to rock forwards, so the radius of that curve is the same radius from there to there, which is don't know what it is, 54 mil. So now I'm going to cut 2 of these out of some thick steel, I think 6 mil, and offer it all up and see if it looks right, and if it looks right, tack it up. Right, after some bandsawing, we now have 2 rough cut fingers. I say the rough cut, I've not tried to file them or fettle them or anything. There's no point yet. I need to know if they actually work. So the way they will go is one will go in there like that, and one will go in there like that. So that is basically what it looks like. So if we now try and offer it up to the gearbox, see if we can work this, do this. Right, that is basically what it looks like. So this will pivot and push this forwards. So I think that seems to be pretty good actually. Notice it's got these shoulders so that the bearing can't spin. And what I think I will do now, on the strength of this, I will fettle these. You can't beat a good bit of fettling. I will fettle these and file them because I do have some pride, and clean them all up, and then we'll tack them onto this shaft presumably it's central, tack them onto the shaft and try it and see if it works. And if it works, then we'll do the full welding job. So after a bit of TIG welding and much fettling, this is the lever. So you will have noticed that there was a tube in between here when I was welding it. That was basically just a spacer. I could clamp everything solid and weld it up to here. Now it's obviously gone. I've also done a bit of fettling on here, and I've basically relieved these out slightly so that it slots in like that. So let's whack it on and give it a test. So there it is. Obviously it goes like that. And I think that's going to be fine. I think that's going to work. Quietly confident. Obviously you now need to put, well, two more things to do now and then it's pretty much done. I need to put a lever arm coming down here, and I'll make that the same way as I made these. And this shaft here that sticks through, all I'm going to do is just drill a hole and have a split pin go through there. I was going to have a nut and a bolt and thread, but there's actually there isn't much clearance here, so I'm just going to make a couple of spacers, split pin, and that's that sorted. So let's quickly do that. Right, sometime later, and I've made this arm that sticks down off the bottom of this lever arm. And I made it in the same way as before. I cut the hole first, and then I made the bracket or the finger around the hole to make it easier. Welded it up, fettled it, filed it, smoothed it out, so that's all right. It'll need a hole in it. Bryan will have to put the hole where he wants the hole to go, depending on how the mechanism works. It'll either be a rod linkage mechanism, or it could be a cable. I'm sure a cable would work. I also drilled holes in there. So let's just put it all on and make sure it all works. So that slots in there like that. That slides over there like that. That pin goes in there like that. And that's how the bearing works. And that's it. And that, Bryan, is all you asked me to do. However, there's a but. And the but is, remember when I took this out and this bearing was on it? Well, I took the bearing off, washed it in hot water and ferroliquid, and it is completely knackered. There's good 1/2 mil of play in there. So we need a new bearing in there. And while I'm at it, we may as well delve a bit deeper into the gearbox, because we might as well just check everything else, mightn't we, really? There's no point going to all this effort and giving him back a gearbox that's not actually finished. Also going to clean this paint off. I know he wanted this red paint taken off as well, so I'll just whack it all on the bill. I'm not quite sure what I'm going to have off him. Maybe one of his cars. What do you reckon? Interesting to hear what you think. Anyway, so I think I'm going to have to order another bearing, and I'm going to have to delve into here. So to be continued. So it's mission accomplished, given that the original mission was to sort out the selector mechanism and sort out the clutch release mechanism, but the mission has now grown. I've seen that input bearing and it's completely knackered, so I've got to delve in there and see what else is going on. Otherwise, it's all a bit pointless, really. But if you want to see that, you're going to have to tune in next time. So if you like that, please do hit like. If you want to see the next one and you're not subscribed, hit subscribe. Please do leave a comment. Let me know what you would have done and what you think of the story so far. And if you want to support the channel, please consider getting one of these t-shirts from my shop, which is just there. But I think for now, that's about it. So thanks for watching.